All right, welcome to Chapter 4. Once again, this is Section 2, Part 1. So this is a two-part section. We're going to concentrate on operations of functions today. And remember, all operations are adding, subtracting, multiplying, and dividing. That's what we're going to learn how to do. And we're going to perform those operations on functions. Okay, so we're going to do operations on functions. Okay, so remember what a function notation looks like. F of x, all it is a function. It's not anything fancy. G of x, same thing, would be a function. H of x, a function. So it doesn't matter what letters they're using. If it's in this sort of notation, f with an x next to it, that means that is a function. Okay, that's all that means. All right, so function operations. Okay, first operation is sum. Okay, remember sum means to do what? Sum means to add. Okay, and there's two ways to write it. We can do f of x plus g of x, or we can write it f plus g of x, meaning you add f and g together. Same thing with difference. Difference is what operation? Hopefully you remember. Difference is subtract. You can either do f of x minus g of x or f minus g of x. Same thing. Third one is product. Product, I'm sure all of you know, product means to multiply. F of x times g of x or f times g of x. And last one is quotient. Okay, last one is the quotient. And you can write it two ways. Hopefully you remember that that's quotient means division. F of x divided by g of x or f divided by g all of x. And please remember that g of x cannot be equal to 0. Why can it not be equal to 0? Because when you have 0 on the bottom of a fraction, it's equal to undefined. That can never happen. So the bottom can never be equal to 0. Okay, so please don't forget that. All right, so let's look at some examples. Okay, we're going to do this example here. It says f of x equals x plus 3. F of x equals x plus 3. G of x is x squared plus 5x plus 6. And the first problem they want us to do is add f plus g of x. So we're going to add x plus 3 to x squared plus 5x plus 6. So x plus 3 plus x squared plus 5x plus 6. Okay, now what like terms do we have here? Let's start with the highest exponent. We only have 1x squared, so I'm going to bring it down. X plus 5x is 6x. And we have a 3 plus a 6, which is 9. So f plus g of x is x squared plus 6x plus 9. Okay, hopefully that makes some sense. All right, now the next one says to subtract f minus g of x. So f is x plus 3. We're going to subtract x squared plus 5x plus 6. All right, so let's start with the highest exponent. It says minus x squared, so negative x squared. X minus 5x. So this is 1x. 1x take away 5x is negative 4x. So those are gone. And then I have a 3 minus 6. 3 minus 6 is negative 3. Okay. I don't think that's too hard for you. I think you'll be okay with that. All right, we're still on the same problem. I just changed pages. Still the same two functions. The next part C says to f times g, f times g. So I'm going to take x plus 3, and I'm going to multiply it by x squared plus 5x plus 6. Okay, so the only thing you have to do here is make sure you pay attention and do it slowly. X times x squared is x to the third. X times 5x is 5x squared. X times 6 is 6x. Then I do the 3. 3 times x squared is 3x squared. 3 times 5x is 15x. And 3 times 6 is 18. Okay, now we have to gather all of our like terms. We have an x cubed. We have 5x squared plus 3x squared, which is 8x squared. We have 6x plus 15x, which is 21x. And then we have plus 18. Plus 18. Okay, so there's our final answer for the multiplying. So that's obviously a little bit longer. All right, so next one. Next problem says to divide f by g. Okay, so what we're going to do is, get marker back. x plus 3 divided by x squared plus 5x plus 6. Now, anytime you do division of functions, you should be thinking about factoring. Okay, so what can I factor here? I'm going to take the top. Let me move this a little bit to make it a little bit nicer to look at. Oops, not like that. Okay, I'm going to rewrite my problem down here. Okay, on top, there's nothing I can factor. It's just x plus 3. Now, on the bottom, I can factor that as an x squared. To x and x. What two numbers multiply to be 6 but add to 5? Hopefully you know that that's 3 and 2. Alright, now let's look here. Notice this is all being multiplied, and we have an x plus 3 over an x plus 3. That cancels because that's 1. So my final answer is 1 over x plus 2. Now, think about this. What can the bottom not equal to? It can never equal 0. So what number can I not put in here to make it equal to 0? What number plus 2 equals 0? So x cannot equal negative 2. Negative 2 plus 2 would be 0. So the answer is 1 over x plus 2, but x can never equal negative 2, and you gotta state that. Okay. All right, let's do another problem. Same exact thing, just two different functions. So my new functions are f of x equals and g of x equals 2x. Okay. So now first one says let's add. So I have 4x squared minus 2x plus 2x. So 4x squared plus 2x. So let's add. 4x squared is my only x squared. Negative 2x plus 2x. So those are opposites and they cancel. So I'm left with 4x squared. Okay, now let's subtract. Next one says subtract. 4x squared minus 2x minus 2x this time. Oops. All right, so I only have one x squared, so I just bring it down. Negative 2x minus 2x. Now how many negatives is that? Negative 2 and another negative 2 is negative 4x. So 4x squared minus 4x. All right, moving on. Once again, notice that they're the same two equations. They have not changed. We are going to now multiply f times g. So 4x squared minus 2x times 2x. So basically this is just a distribution problem. 2x times 4x squared is 8x to the third. And 2x times a negative 2x is negative 4x squared. No like terms, so I'm done. Next one, f divided by g. So I have 4x squared minus 2x all over 2x. All right, so I said in the last problem, when you're dividing, you should always think about factoring. Okay? So if you notice the top, I can take out a 2 and I can take out an x. So 4 divided by 2 is 2. I had 2 x's, I took one out, I have 1 left over. Minus 2x, I took out a 2x, so I have a minus 1 left over. And on the bottom, what do I have? 2x. So what can I cancel out here? Hopefully you recognize that I can... Okay, hopefully you recognize that I can cancel out a 2x with a 2x, and I'm left with 2x minus 1. Okay, so I'm left with 2x minus 1. Hopefully that makes sense. That's adding, subtracting, multiplying, and dividing two functions. Okay, and last but not least, we have some graphing problems to look at. So notice, we have two graphs here on the same xy plane. We have a blue graph, which is my f of x, and we have a red graph, which is my g of x. Okay, so now let's look at the first problem. It says find f plus g of 5. And remember, this number right here is always x. So x equals to 5 is right here. Okay, so what is the red graph equal to at 5? And hopefully you see that that is equal to 3. Okay, so my red is g, so at g, my problem is 3. And what is 5 equal to on the blue graph? All the way up here, what is this number? Hopefully you see that that number is equal to 6. So what is 6 plus 3? 9. Okay? All right, now we're going to do the same thing, except we have a different problem to do this time. Same two graphs. And what it wants to know is what g minus f of 2 is. So I'm going to find x equals to 2 and circle it. And now let's figure out what our graphs are equal to at 2. Okay? So my blue graph at 2 is equal to 6. What's my blue graph? F. So this is 6. And what is my red graph equal to at 2? If you have to, now it's not on a line, but you can estimate what is that equal to? Probably 1.5. 1.5. So what's 1.5 take away 6? Negative 4.5. 1.5 take away 6 would be negative 4.5. Hopefully that makes sense. I think this is a little bit easier than the last section for you. Have a good night. I will see you tomorrow, and we will make sure we fix any mistakes that or questions that you have. Thank you.